This is part 3 of reverse engineering a droid personality chip. This video picks up right where part 2 left off. We had created a schematic and this rudimentary PCB design that you see on the screen now. And we're going to continue working on this PCB design. I'm going to close this for now. I want to come back into our schematic because there's something here that I want to add, and it'll help both address that warning about the missing nets, and it's also going to help creating the PCB. What I want to do is I want to create a schematic symbol and a footprint for those gold fingers. So the way I am going to do that is I am going to come up to File, New, and I have Symbol and Footprint here. I'm going to do a new symbol, and it is as simple as just drawing out whatever it is you want. I'm going to have several pins here. There are 7 pins on the connector, on the fingers, right, for the personality chip. So 1, 2, 3, 4, 5, 6, 7. And now I'm going to do something to represent those fingers, but I can see the grid here is maybe a bit too wide. I want to reduce the grid. How can I do that? Grid size. I'm going to change that to 5. If you look on the right here, it's I've selected pin 1 here, and it's got the pin attributes. The name of the pin can be whatever you want it to be. The number is important when you're connecting your footprint that you designed to the schematic symbol that we're creating right now. You're going to need to mark on your footprint what copper area belongs to which pin. So the numbers are important. I'm going to leave them as 1, 2, 3, 4, 5, 6, 7. But the name, I can change the name to what I have them on the schematic here. So, for example, I know that what here is listed as pin 1. I know that's ground, so I'm going to call that ground. And pin 7, I know that is V. Do I want to call it VDD? Sure, why not? And then what do we have here? The second pin connects to pin 5 on the chip, which is the serial input pin. Gold finger 3 is connected to pin 2, which is the serial output. Pin 4, I'm going to stick with calling that VDD. Can I still call that VDD? I think so. Actually, you know what? I'm going to call that the detect pin, because that is, if there's voltage on that pin, that is how your droid knows that there's a personality chip. That's why pin 7, power on pin 7 and pin 4 are connected together. So that way voltage comes in through pin 7 from the droid and then goes out through pin 4, so the droid knows that there's something connected, there's something plugged in. So I'm going to call that the detection pin. The pin after that, pin 5, is connected to pin 6, which is the serial clock. And that one is connected to pin 1, which is the chip select pin, and I'm going to put that hash symbol after it. And then what else do I want to do here? I could do something like this. I could draw a line. And now we have a schematic symbol that represents the gold fingers of the memory chip. So I'm going to File and Save, and it should ask me, do I want to set the origin automatically? Sure, do your thing. Now will you let me save it? Yes! Personality, Droid personality chip card edge. Cool. Now the next step is to create a footprint for this. The footprint will be the representation of this on the actual PCB, so the actual gold fingers. This is where the measurements will come into play. Let's make a footprint for this. So I am going to go into File, New Footprint. And I want the units here to be in mils. Okay, time to create the footprint. The first thing I want to do is I want to create one of those gold fingers, and then I'm just going to copy and paste it a few times. So I'm going to use a solid region here, and I'm just going to draw a rectangle. I don't really care about the dimensions yet. Well, maybe I do now. There we go, 4 points. Nice rectangle. Now I'm going to right click on it and click Convert to Pad. And now this means that this is something that a wire can connect to, which is what we want because this is what we're going to be connecting the memory chip to. When it gets converted to a pad, it gets new properties on the right hand side. First thing I want to do is change it from a polygon to a rectangle because it's only got 4 corners, or it should. Now I can specify the width and height. I know the width is 60 mils and I know the height is going to be 300 mils. There we go. It talks about solder mask here. I'm going to set that to 0. That removes that so that the solder mask will come right up to the edge of the board of this pad rather than or this gold finger, I should say. The solder mask will come right up to the edge of this gold finger rather than having an area around it that doesn't have any solder mask. Alright, that looks good. So, armed with one of those, I want to change this grid here to something that's going to be a little bit more beneficial for spacing this stuff out. I'm going to change the grid layout here to 100 mils. And I know that the spacing between pins is 100 mils, so I'm going to just copy and paste 7 of these and put them on each line. I want the snap size here to match the grid size, so I'm going to change that to 100 as well. So now I know I am going to be aligning these exactly 100 mils apart. So I'll copy and paste that. 4, 5, 6, 7. Excellent. Now I need to change the pad properties here. You can see that there's a number associated with it on the right hand side, just like the footprint. I need to change these numbers to match the footprints. The schematic symbol, I mean, not this. We're working on the footprint. 5, 6, 7. Perfect. The next thing I want to do is I want to change the height here because I know the height's a little bit different. So I know from my notes that, what are we looking at? 270 for these 4. So I held down the control key while clicking on all 4 of these. And I will change the height to 270 mils, like so. And then the middle one, I'm going to change the height to 240. Now if you notice, it centered on the middle here, not on aligning them all to the top. We'll have to fix that in a moment. And I'll do that by changing the grid snap size here to back to, we'll call it 10, say. I'm going to also reduce the grid size here a little bit. Why is it based on the center here? That's not good. I need all of these things to be lined up on the top exactly. And it does not want to do that. That's okay. If I click on these, I have a position, center X and center Y. And I know minus 100 for this one, and then minus, is it 70? Why is it minus 85 here? Why is that minus 85? There is some math reason behind that, and I'm not thinking it through correctly right now. But there, now I have all of these lined up along the top. Good. So I've got the gold fingers for one side of the PCB. I need to add gold fingers to the opposite side. I'm just going to center these a little bit just because I want this to look a little bit cleaner while I'm working on it. All right, so now I'm going to select all of those. I'm going to hit Control C to copy and Control P to paste. Now it's pasted it to the top layer. I want to move these to the bottom layer, so I'm selecting them all. And then on the top right here, it says layer for these objects. It's all top layer. I'm just going to select bottom layer. And now they're all moved to the bottom layer. They've all turned blue. I'm going to highlight the bottom layer by selecting it under this layer in objects list. Select all of those things again. And I'm going to drag them all down until they line up with the top side, like so. So now in theory, if I turn off the bottom layer, the top layer is exposed, and we can see they're lined up on top of each other. Great. The other thing that's we need to think about real quick is on the backside of the chip, the bottom layer, the numbering is going to be reversed. So when we're looking at it from the top of the PCB, pin 1 of these fingers is on the left. When I highlight the bottom layer, I'm looking at the bottom layer as if I'm looking at it from the side of the top layer. So I'm seeing the mirror of what this will look like when it's flipped over. In other words, these pins, the numbering here needs to be changed. So instead of 7, this becomes 1. This becomes 2. This becomes 3, 5, 6, 7. And now I need to save this. And I'm going to, actually, before I save that, there's one other thing I think I want to add here. Something that we see on the stock personality chips, and that is text. Text that says VDD and ground. That's a bit big though. I'm going to change the size here to, I think 32. I can come back and revisit this later, but there are minimum sizes. There's minimum line widths, depending on the tolerances or the limitations of the company that's manufacturing your PCB. I'm going to need to look those up. Right, so it is roughly going to be a line width of 6 mils with a height of 32 mils. And it should be oriented like that. And then if I take this and bring it over here to the right and put this as, do I want to put VCC or do you want to put VDD, like the stock personality chip? Maybe I'll move that out a little bit like that. And then if I take those, select them both, copy and paste. But now, if I bring them to the bottom silk layer, rotate, and now I can see I have markings on both sides. And I'm turning the top silk layer on and off just to make sure that they're lined up in the same spot. So everything's got a nice alignment to it. In fact, I could potentially even bring it down just a little bit on the bottom side here. Yeah, close enough. Okay. We have our footprint. Time to save it. Droid, oops, title. And it's not letting me use lowercase. Footprint naming reference. Ah, there's a formula. And it wants to know about pin pitch, package width, package height, all of this stuff. Package type, feet number, body width, foot distance, body length, foot azimuth. I'm just going to call it 7P 200 mil. Actually, it's 100 mil card edge. Whatever. It doesn't matter. So now I can come back over to the schematic symbol and I can add a footprint to it now. And I can add the footprint that I created. No, I want mine. There it is. Look at that. And now we can work on the pin, or we can double check that the pins are connected up properly. Pin 1 is ground, 2 is serial input, all that stuff. And it matches the pins over here. Yeah, looks good to me. Click on update. It has matched the schematic symbol with the footprint. I'm going to save the schematic symbol. And now I can go back into the schematic. And now I can add from the library here my droid personality card edge like so. Wonderful. And now I can do some nets here. This is a part of the tediousness of creating these sorts of things. There's no quick or easy way about it. What I'm going to do here is I'm going to use these net port symbols to sort of signify the different nets that I have coming in here. All right, so this net I'm going to call VCC because that's the net that it's connecting to. This is connecting to ground. The rest I will call what I have on the schematic symbol. The detection pin is going to be connected to the VCC net, so I'm going to leave it. I'm going to call this VCC here. This symbol, the square with like an arrow on one end of it, that's as it shows when I was putting them down initially, it was calling a net port. It's like an entry point into or a connection to whatever net you specify. So for example, now I can take this serial input. I could do a copy and paste here if I want. And I can bring it over here and connect it to pin 5. And now the serial input, which is on pin 5 here, is connected to the serial input net, which connects to pin 2 of the gold fingers down here. And now I'm going to do the same for these other connections here. That is already done. Chip select. Serial output. What else do we need to connect? I think that's it, just those 4. And now we have a nice schematic here that's got everything we need in it. There's still one more change to it that I'm going to make, but for now, I'm happy with what we have here. Because I've changed the schematic, I need to update my PCB design. So if I come up to Tools, right below where it says Convert to PCB, I can click on Update PCB, and it's going to update my PCB. This window that just popped up, the design rule window. So in the past, when it warned me that not all the nets were connected, it skipped over this. But now that all the nets are connected, it didn't give me that warning, and now it's giving me this design rule window. This is where you specify minimum trace width, minimum silkscreen width, minimum distance between traces, minimum distance from holes to other things, minimum distances, tolerances, that sort of stuff. In Easy EDA, their defaults are going to be at or more conservative than what OshPark, for example, needs. So you could leave them as is, or you could go online and you could find the website or the web page on OshPark's website that talks about what their minimums are. This page here contains all of the specifications for OshPark's 2-layer prototype service, which is the most common service. That's what we're using when we order the personality chips through OshPark. And if we scroll down here, it's going to start to talk about some minimums here. Silkscreen, minimum line width, 5 mils. So if you remember earlier, the text, the VCC and ground, or the VDD and ground that I have on that sitting next to the gold fingers, I had those as a 6 mil width. So we're within spec there. We should have some other minimums here. Trace spacing. That means traces need to be at least 6 mils apart from each other. Minimum width of a trace, 6 mils. This talks about, I forget what that talks about. Board edge keep out, that's something we're going to have to worry about later. You need to have at least 15 mils between the board edge and anything that's in your PCB design. Minimum drill sizes, which refer to the smallest holes that you can have in the board, that sort of stuff. We can take all of these values and we can bring them back into Easy EDA and put them in here, but all of these values that are in here by default are at the same value or larger, meaning they're compatible with OshPark. So I'm going to just leave them as is. And now we have gold fingers to place on the board. And I want that to be roughly in the middle. So I'm going to change the snap size here to something large. And there we go. We have gold fingers now. And if I save this and view this in 3D, look at that. We have gold fingers now. We're getting there. But now, of course, we need to connect the gold fingers up to everything. And this is where the fun really starts, because now you have to run wires between these gold fingers. You have to run wires both to the front and to the back gold fingers. This is where there's a million different ways to do it, and it's not necessarily that all of them are equally good or bad. Because of the size of the board, you could wire this up probably any way you want. You could run traces all over the front and the back, and it'll be fine. On larger boards, on more complex circuits, how you lay out the traces on your board can have serious impacts on how the board operates, or it might not work at all. This is something that's going to take some playing around with, but I'm going to start and we'll go slowly through this, through the first few wires that I add, and then I'll probably finish the rest of it off camera and then come back and show you the completed thing. One thing I want to do first is, you see it says U2 here. That's the reference designator. It's given to these gold fingers. Now, actually, I don't like it using the letter U for the gold fingers, because that's a connector. So I'm actually going to go back into the schematic symbol, and over on the right here, under custom attributes, there's this line called pre, and then that's setting the reference designator. U, and then a question mark. Question mark will be the number that it's assigned. So I need to assign it something else. What letter do I give it? Well, Wikipedia has a page on reference designators, so I'm going to look at that and see if there's anything here that has to do with connectors. So J, which stands for Jack, is the least movable connector of a connector pair. Maybe. Or P, plug, the most movable connector. So I guess you're taking the personality chip and you're moving it into the droid. So maybe P is the correct reference designator. Or X here for a socket connector. For a vacuum tube socket, a fuse holder. You know, X might be the correct one here. So I think I'll go with X. So I'm going to go back into Easy EDA, and I'm going to change this from a U to an X. And I'll save that. Come back into my schematic here. And I'm going to have to manually change that, it looks like. So I'm going to just call that X1. Save that. And I don't have to, but I'll go update my PCB. And now it's called X1. But I don't want that text there, that X1 text. So I'm going to select that component. And is there an option here? There is, I just need to select it. There we go. I guess all the layers that this thing exists on need to be visible before you can select the whole component. But now that I've selected it, over on the right hand side it specifies the prefix, which is X1. Display it, I'm going to select no, I don't want to see it. I could also just select the prefix on the board and hit the delete key. Likewise, U1 here. I don't want that to say U1 actually. What I think I want to do here is, because I want this PCB set up in such a way that it'll let you know, it'll remind you what's supposed to go where. Instead of it being U1, what I think I'm going to do is hide that And I'm going to come in here. I'm going to put text down. First, I'm going to select the top silk layer. Actually, I'm going to do something better. I'm going to go back into my schematic, and this is the name of the item here, this P25Q80. I'm just going to rename it to 25XX because it's a 25 series memory chip. That's the only thing that I want to be here. It doesn't have to be the specific P25Q80H. It could be a WinBond. It could be any number of other manufacturers' flash memory chips. So I just want this to be called a 25XX, which is similar to the designation that you see on that little $10 programmer that I've used to program personality chips. So I'm going to update the PCB, and it's going to rename that to 25XX. Display name, yes. And now I can put this anywhere I want on the board. I'm going to change the size though from 45 to 32 mils in height. I'm going to put that underneath or in the middle here of that memory chip footprint, so that way when you put the memory chip in place, that's hidden from view. Okay, that was a bit of a sidetracked thing. Now let's go back to wiring up the fingers on the PCB here. So I'm going to hide the silk screen for a moment. We're focused on the top layer. Now we're looking at the bottom layer. And the thing is that middle pin is the same on both layers. So a quick and easy way to wire those up is come up to the PCB tools and select via. Vias are holes that go through the PCB. They're plated through holes, meaning that they form like a wire that goes from the top side of the PCB to the bottom side. So I'm just going to place that there, and I'll call this VCC. I'm going to add it to the VCC net, like so. And now I can run a wire from the middle pin up to that via, and then I can select the bottom side and do the exact same thing. And now both gold fingers are connected to that VCC via, which I can then run off to wherever I want. Now at this point, I want to change the grid side here, the grid size here, because it's too big. It's going to be easier for me to work on this if there's a smaller grid size. So I'm going to change this to, I don't know, what's 50 look like? 50 might be a little bit better. Snap size, we'll stick it at 50. The corners here on the personality chip are a little too big. I think I want to change that. The alt snap size, I'm going to do 25. And I'm going to hold down the alt key. And I'm just going to make the corners a little bit smaller. And by doing that, I can bring down the gold fingers, run them a little closer to the edge of the PCB. And then if I want, I can move this via down too. It doesn't have to be all the way up there. In fact, if you look at the stock PCB, this via is actually about right there. And we could put ours there too. But I'm going to leave it a little bit above, just because the silk screen is going to go over that via. The solder mask is going to go over that via. And it's going to, when that solder mask is applied, it's actually going to fill in that via to make it less visible. Whereas if I had it down here as part of the finger, it wouldn't necessarily be filled in because it's part of this pad that's going to be exposed. So I'm going to bring it up a little bit away from the gold finger here. I'm going to speed through this next bit here just to try and get things going a little faster. What I'm trying to do here is I have these fingers on the top and bottom of the PCB that make contact with the socket that's in the droid. The fingers are mirrored. If you look at the PCB from the top, the ground finger is on the far left. But if you look at the bottom layer of the PCB through the top layer, the ground pin or the ground finger is on the right-hand side. So this creates a unique problem where I need to connect the ground fingers that are on either side together. And I need to do the same for all the other pins or all the other fingers that are on there. So the second from the left, if you're looking from the top, is the serial input pin. And the second from the right on the bottom layer is the serial input pin. I need to connect those together. And the same with the chip select pin, the serial clock pin, the serial output pin. These are all things that need to be connected together. And rather than run traces on both the top and bottom of the PCB and just try to figure out where to connect these things together later, I want to take care of that now. The idea here is to run traces on the bottom layer going horizontal. And just as it gets close to one of the fingers, use a via to bring the trace from the bottom layer to the top layer and connect it to one of the fingers. So what I'm creating here are these series of what look like arches going back and forth on the bottom layer here. And their purpose is to connect the fingers together, the top and bottom fingers together. That way, once all of this is taken care of, I don't have to worry about it. I don't have to think about it later. I can focus on getting the memory chip and the resistors and capacitors located and wired up, and then I can just bring the traces from that half of the circuit down to the fingers where they're already wired up. In the long run, my hope is that this just removes a little bit of headache on my part. That's the hope anyways. So that's what's happening right now. I'm trying to figure out how I can wire these things up. The blue traces that you see, those are all on the bottom layer. I'm trying to only do traces on the bottom layer for this. Occasionally I'm trying out different ways here. I will eventually need to have some traces coming up from the fingers on the top layer. I'm trying to refrain from doing that until that it's absolutely necessary. Before I continue laying the PCB out, there are a couple of things that I need to change. I need to come back to the schematic here for a minute. There's a component here that I want to add. It's not required. You could come back later and delete it. You don't need it, but I'll explain what it's for. I want to delete hold from connecting directly to VCC, and instead I want to throw in a resistor. And I guess I'll put it in like that. Wire this up. And I'm going to need to find a cleaner way to add that into the circuit later. Maybe something like that. I'm going to call this R99, and I'm going to give it a value of 10K. So what does this resistor do? The hold pin was previously connected to power. If you were to solder this chip to your personality chip, solder the memory chip to your personality chip, and then try to program it by using a chip clip, which clips onto the chip, directly connecting to the pins of the chip, and then plug it into your programmer, what's going to happen is your programmer is going to output power on the power pin, pin 8 here. And then that power is going to come out of your programmer, and then it's connected directly to pin 7, so then power is going to be coming back in through pin 7 of your programmer. Some flash memory chip programmers won't care about that. Others absolutely will. You could even wind up damaging your programmer. What this resistor does is it still connects the hold pin to power, but it's putting it through a resistor to limit the amount of current that will be going into that pin. So if you're in an instance where your programmer is going to try to sync the current coming in on that pin, that is, if there was a short, it would damage your programmer. Well, that resistor now is going to limit the amount of current coming in through the power pin to a very small amount, and that should be less than the amount that would cause any potential damage to your chip programmer. So that's why I've included it on my previous personality chip designs. That's why I'm going to include it here. If you use something like the personality chip to DIP 8 adapter that I covered in a previous video that I made, then you don't need this extra resistor. You can get rid of it and you don't have to worry about adding this. If you're using a chip clip, though, this is probably something you want. I think most people are probably going to be using the chip clip that came with that little $10 programmer from Amazon, so I'm going to keep that resistor in this design. Since I've added it to the design, I now need to go back and update the PCB, and it's going to be adding R99, and there it is. Back in the schematic for a second, I want to also add some net names that are missing here. Just so that way when we're building the PCB, instead of having some weird auto-generated number for a net name, we can see something that's more readable. For example, this write protect trace here, I'm going to call that write protect, so I know what that is for. And I'm assigning that, I'm giving that wire the net name there by using this net label under the wiring tools here, this net label button. Likewise, if I come over here to the hold pin, I can now take that net label here, and I can, the wire that goes between the hold pin and the resistor, I can now name that hold. And that's probably confusing, and I can clean up the schematic later so it's more obvious that pin 7 is the hold pin there. Save that. I'm going to update the PCB again. And now if I zoom in, I can see that the hold pin is connected to the hold pin net. I can see that the write protect pin is connected to the write protect pin net, so everything looks nice and readable, and you understand what every pin on this chip does. So that just makes life a little easier, a little bit more convenient when you're working on the designing the PCB. Not necessary. You could leave it with the weird U1_ pin number as the auto-generated name of that net. There's no reason other than for your own desire or to aid in your understanding of the design that you're creating. So now we've got a fourth surface mount component here to add, that resistor. We'll have to figure out where to place all of this stuff next.